Clocks don't measure time, they measure themselves. A second is just 9 billion wiggles of a cesium atom. We didn't find time, we built it. So, what does a moment really mean? What is a slice of time? To answer that, we have to break a strong intuition. Hey, I'm Jess with Meet the Scientist. There is no single now that the whole universe agrees on. Now depends on two things: how fast you're moving through space, and if you're close to something massive with a lot of gravity. If we drew a timeline from the Big Bang to now, you might think that the end of the line is the same for everyone, right? Well, not exactly. This is now for me right here. But let's say there's an astronaut traveling 10% the speed of light. For us on Earth time, we'd move quicker into the future, but they would fall behind to our past. And if you traveled near a black hole, time for you would also slow down relative to everyone far from it. For someone circling just outside a black hole, seconds for them would be years for us. This isn't just a theory. You can test this at home if you find yourself with two atomic clocks. If you attached one to your head and one to your feet, the time difference is measurable. Over the course of your lifetime, your head will be about 30 microseconds older. Our feet are often closer to the Earth and its gravity. The difference is tiny but measurable. Without correcting for this relativity, our GPSs would go adrift by miles a day. Your phone's map only works because we constantly adjust our satellite clocks to account for these space-time changes. So, we measure time with machines, but we also feel it passing. And your brain's now is less instant than you think. There's a phenomenon called chrono-stasis. Check this out. Look away, then look at this clock. The first tick of the second hand often looks longer than the rest. That's because your brain backdates to the moment that your eyes started moving. Your present moment is slightly delayed, stitched together from the recent past to keep this perception running smoothly. Without this editing, the world would jitter and jump every time you moved your eyes. Editing our now is one thing, but how do we sense minutes and hours passing? Why does time drag sometimes, but not others? One of the many ways that your brain keeps track of time is by rhythmic pulses in your basal ganglia, like a biological metronome. Interestingly, when you're paying close attention to time passing, like when you're bored, more pulses are counted and time seems to drag. But when you're absorbed or distracted, fewer pulses get counted and time flies. Another is memory density. The more distinct things that your brain encodes, the longer the span feels in retrospect. Vacations packed with novelty feel long in memory, while repetitive weeks seem to blur together. Childhood feels long, partly because everything is new. In adulthood, everything speeds up because your brain stops saving redundant details. In dangerous or exciting situations, arousal neurotransmitters like norepinephrine increase neural firing and memory sampling. Later, those memories feel slowed. Not because the world slowed, but because the brain recorded more frames. But what if your memory failed completely? What would time feel like? In 1985, musician Clive Wearing suffered brain damage that left him unable to make new episodic memories that help us recall previous events. He lives in 30-second loops. Each time he recites, "I am awake for the first time." For him, the thread of time doesn't flow, it restarts. But even when conscious time shatters, the body still keeps track. We talk about the body clock as if it's singular, but it isn't. Your body is a network of clocks called the circadian rhythm. A master pacemaker in the brain synchronizes to daylight detected by your eyes. Many organs, including the liver, muscles, heart, skin, and immune cells, keep local time using tiny molecular feedback loops as clocks. that switch on and off over 24 hours. Your liver tunes itself to meals, your muscles, skin, and even your gut microbiome pay attention to your daily patterns and schedule accordingly. So, what is the shortest amount of time that we can notice or perceive? Well, it depends on what sense that you're talking about. For vision, it's about 100 milliseconds where multiple flashes will kind of merge into a blur. For multisensory events, the brain tolerates about 250 milliseconds out of sync before it notices something going wrong, such as speech lagging behind lip movements. Speaking of milliseconds, why are there 60 seconds in a minute and 60 minutes in an hour? Why not 100? Long before modern clocks, ancient Mesopotamian astronomers used base 60 because 60 has a ridiculous amount of denomination. 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. This makes fractions easy without calculating. And if you ever wondered why we called them minutes and seconds, it's because minutes directly translates to the first small part, and second translates to the second small part. Okay, if you're looking for opportunities to time travel today, you kind of can. Because light has a speed limit, the universe has a museum of the past. The moon, you see, is 1.3 seconds in the past. The sun, just over 8 minutes. And the closest star, over 4 years away. And with our space telescopes like the Hubble and James Webb, we can see even further, up to billions of years away, close to the beginning of the universe. Some of the stars we see are already long gone. A telescope isn't a window, it's a time machine. And the cosmic microwave background, the faint microwave glow in every direction, is a baby picture of the universe, released when it was only 380,000 years old. Before that, the cosmos was an opaque plasma. As it cooled, atoms formed, and light could travel freely. We still see that first light today in microwaves. It's the oldest light we can see. And we're not just receiving light, we're also sending it. For about a century, Earth has been leaking radio, TV, and radar. Those signals form a growing broadcast bubble over 200 light years in diameter. But due to the inverse square law, these signals get faint fast, just a few light years away from Earth. But where is Earth exactly? If our time can't be pinned down due to relativity, what about our location? The thing is, we're never really in the same spot twice. I mean, you're able to find your home in the same spot it was yesterday, but in the context of space, your home would be about 47 million kilometers behind. Earth's always in motion around our sun, around our supermassive black hole. But okay, what if we just have a map, right? Then we'd be able to figure out where we're headed. Well, when the universe began, it didn't explode into empty space. Space itself expanded everywhere all at once, like the surface of a balloon inflating outward. In that sense, anywhere in the universe could claim to be the center. So the only way for us to really know where we are is in relation to other celestial objects. So location is kind of relative too. We're on Earth orbiting a star halfway out in a spiral arm in the Milky Way, in the local group, moving within the Laniakea cluster's flow. There is no fixed here and now. This moment that you're experiencing is a connection point, dependent on the entire universe. That's all for now. Thanks for your time.